If we're given that the cosecant of the angle theta is equal to 13 divided by 12, and then we're asked to find the sketch, very good place to start, the sketch, with the acute angle theta. Okay, what does acute mean? Acute means that the angle theta has to be between 0 and 90 degrees. So we're going to label the acute angle between 0 and 90 degrees of theta in the sketch that we're going to draw. And then we're going to find all the other trigonometric functions. So let's get started with the sketch. First, we'll draw a right triangle with a 90-degree angle. Now, we have to come up with theta in a location of one of the acute angles. Now, the 90-degree angle could not be theta, because remember, theta has to be between 0 and 90 degrees. It cannot be equal to 0. It cannot be equal to 90, and it can't be outside of that range. So we're going to choose one of the other sides to be our theta. So we'll choose this smaller angle here to be theta. And now let's label the sides in such a fashion that the cosecant of our theta is going to be 13 over 12. So we just remember that what cosecant is defined to be equal to in a right triangle, it's the hypotenuse over the opposite side. So we'll label the hypotenuse 13 and the side opposite theta 12. That makes sure that theta, the cosecant of theta, is 13 divided by 12. Now, we can figure out the missing leg using Pythagorean theorem. It's going to be 5, and let me explain why. The hypotenuse squared, according to Pythagoras, is equal to the adjacent side squared plus the opposite side squared. So solve for the adjacent side. We get the square root of 13 squared minus 12 squared. So that's the square root of 169 minus 144, and that's the square root of 25, which is 5. So that's where the 5 came from. Now we have a nice right triangle with all the sides labeled, and here's theta. Then we have 5, 13, and 12. Okay, now we can proceed in identifying the value of all the trigonometric functions. Just remember the definitions. On a right triangle, sine theta is opposite over hypotenuse, so that's 12 over 13. The cosecant, well, that one was actually given to us, but let's do the formalities. Cosecant of theta is the hypotenuse over the opposite, so that is 13 on the top over 12 on the bottom. The next one will be the cosine of theta. That's defined to be adjacent over hypotenuse. So from the triangle, we see that is 5 over 13. The secant of theta is the reciprocal of the cosine. It's the hypotenuse over the adjacent, so it is 13 over 5. The tangent of theta is equal to the opposite over the adjacent side. So on our triangle, that's 12 over 5. And the cotangent of theta is the reciprocal of that. It's the adjacent side over the hypotenuse. The opposite. So that is 5 over 12.